Hello, and thank you for joining me for this presentation on NeuroStack, an AWS CloudFormation-based tool designed to aid researchers working with neuroimaging data using AWS Cloud Computing. My name is Hailey D'Silva. NeuroStack is a data analysis pipeline in AWS designed for neuroimaging data. When you install NeuroStack in your AWS account, you create a series of interconnected AWS services with access to some of the most commonly used neuroimaging software. NeuroStack is freely available and can be found on the NTRK website. Cloud computing is the utilization of computing resources on an as-needed basis. Many large neuroimaging datasets are beginning to be hosted on cloud computing platforms, especially Amazon Web Services, or AWS, and expanding the use of cloud computing for the analysis of NIH data was identified as an objective in the NIH Strategic Plan for Data Science. NeuroStack is built with the NTRK Compute Environment, or NTRK CE, a computational environment developed by the Neuroimaging Informatics Tools and Resources Clearinghouse. The NTRK CE's inclusion in NeuroStack allows users to access all of the software pre-installed on the NTRK CE. This includes some of the most popular software used in neuroimaging projects, such as FSL, SPM, AFNI, FreeCipher, and more. NeuroStack is designed to be easy to use, even if you have limited experience in AWS. It can be used in 5 basic steps. First, create your AWS account, then install NeuroStack. NeuroStack comes with a template script that you can modify for your project. Upload your modified script to a storage area called NeuroStack Script. Upload your input data to a storage area called NeuroStack Input. Uploading to NeuroStack Input will begin processing your input data according to the specifications in your script. Your process data will be automatically updated to a storage area called NeuroStack Output. NeuroStack is free to use, but AWS does charge for using their compute resources, particularly compute time and data storage. NeuroStack can run a wide variety of neuroimaging programs. One such program is FreeCipher's ReconAll, a widely used program that performs segmentation and parcellation of structural neuroimaging data. To demonstrate the cost and time involved in running a realistic neuroimaging project using NeuroStack, we process structural T1 MRI data from the ABCD study using ReconAll. EC2 is the primary AWS compute service in NeuroStack. There are many different families and sizes of EC2s depending on the number of vCPUs, memory usage, essentially how powerful the computer is. We tested several to evaluate the time and cost performance of each. The EC2 families we used were M5, General Purpose, C5, Compute Optimized, and R5, Memory Optimized. The EC2 sizes we used range from .large, with 2 vCPUs, about the same as the laptop I'm using right now, to .24x large, with 96 vCPUs, a very powerful computer. NeuroStack can run EC2s on demand or using Spot. On demand is the standard full-price way to run EC2 instances. Spot takes advantage of compute capability that AWS isn't currently using, and is considerably cheaper than on demand. Let's take a look at the time and cost of performing ReconAll on different EC2 instances in NeuroStack. We'll see that it'll vary widely depending on the type of EC2 we use and if we're running ReconAll in parallel. Running ReconAll in parallel is generally faster and cheaper than running individual subjects. Here we can look at the running time in minutes per subject for ReconAll by EC2 type. It's broken down by EC2 family with the smallest EC2s in yellow and the most powerful EC2s in purple. Running ReconAll individually takes about 5 to 6 hours per subject on average and varies only slightly by EC2 type. Shown here is the result of processing ReconAll in parallel. We can run as many subjects in parallel as there are CPUs on the machine. When we use a .24x large to run 96 subjects at a time, our running time per subject takes as little as 8 minutes. Let's look at the cost per subject when ReconAll is run individually versus in parallel. Here you can see the cost per subject in US dollars when ReconAll is run individually. You can see it varies widely depending on the type of EC2 used. The C5.large Spot instance costs the least at 22 cents per subject on average. The R5.4x large on demand costs the most at $5.88 subjects on average. And here you can see the cost per subject when ReconAll is run in parallel. The cost per subject was less than $1 regardless of the instance used. The cheapest instance was the M5.x large Spot instance at 18 cents a subject. However, as a family, the C5 family was less expensive than the M5 or R5 families at about 50 cents a subject for on-demand and 20 to 25 cents a subject for Spot. If you have any questions about NeuroStack, please visit the NeuroStack forum on the NTRK website. Thank you.